towards this. If you're in the membership program, we've added some videos about this particular strategy leading up to this time. And, when we had to sign up for this program, there was like a one-time deal, like a membership option. If you didn't do the membership and you want to do that, feel free to shoot me a link afterward and we can get you taken care of. So let's see here. Let me show you what I'm going to talk about today. So we're going to show you how to create a profitable cryptocurrency trading bot, but let's give a quick outline. Let's just make sure everybody can hear me okay. Awesome. Good. So here's what we're going to cover. So first of all, in case anybody's wondering, I'm going to give away a complete code solution to this trading bot at the end of this presentation. There's actually a link down below this video with that complete solution. But I'm going to show you how to create the bot with zero downside risk. And I'll explain why that's the case. I'm going to give away the complete code solution. All right. I'm going to show you how to set it up. All right. I'm going to explain how it works. Okay. I'm going to show you how to craft your own strategy with this bot too. It's like how you can change it, extend it, look for more cryptocurrencies, exchanges, all that kind of stuff. And then finally, we'll do some Q&A. So I'll stop periodically to look at the chat for questions, as we go throughout the presentation. But in order for me to concentrate on everything, we'll try to save most of the questions for the end. But like I said, if there's something important that pops up, I'll try to take a look at the chat while we're doing this. But mostly want to try to give as much attention to the presentation as I can. So let's see here. Also, if you're watching this live, especially when we get into the coding section, don't worry too much about following along with me step by step. There's going to be a replay link available later that I'll email out. And if you're inside the membership program, it's going to get added to the video vault. You can always go rewatch this later if you want to follow the setup instructions step by step. But definitely use this time to just kind of get the high level overview of everything, because you may have a little issue like trying to do everything as fast as I explain it. So somebody asks, am I deploying to mainnet too? Yeah, we're going to deploy mainnet. All right. So let's start off with how it works. All right. How does this bot work? So, most cryptocurrency trading bots, they try to predict the future of a cryptocurrency price. Basically, if you have a Bitcoin bot or something like that, it's always trying to figure out where the Bitcoin price is headed. And, there's some people who can make bots like this that work. But that's not what this bot does. And here's why. Those bots are risky. So if you're really good at statistical modeling and can create a model that predicts those prices and looks for, the changes and can create a good model that works on the current market conditions, then they definitely can work, but you run the risk of it blowing up, right? And if it blows up, then you lose money, right? So the bot today does not have that risk. It's zero downside risk. You can't lose money with this bot. The only any kind of money that you could potentially lose would be just with gas fees if a trade isn't successful. I'll talk about that later, but that's really, really negligible compared to how risky some of these other bots are. Okay. So how is that possible? So this bot works on arbitrage. Okay. It's not a price prediction bot. Okay. So basically what arbitrage is it looks for opportunities that exist right now to trade cryptocurrency at a profit. So basically it looks for price discrepancies on different cryptocurrency exchanges. All right. So let me show you how that works. So let's talk about, an exchange. All right. So on one exchange, let's say that Ethereum cryptocurrency or Ether is trading at $100. Okay. And then on exchange B, it's trading at $101. All right. So there's a slight price discrepancy. $1 here. So you could basically buy Ether on exchange A for $100 and sell it on exchange B at a $1 profit, assuming you do one Ether. Okay. Now that's not much to write home about if you have, just one Ether, but there's a few different ways to make this really profitable. Basically, what if you did it with 1,000 Ether? Well, then you can make $1,000 profit. Okay. And what if you could do it with 1 Ether, but you could do it 1,000 times, right? You could basically increase the amount of cryptocurrency or increase the amount of times you perform this operation. So both of those are examples of scaling. So scaling with more Ether is what I would call vertical scale. Basically, it's like increasing the amount, and then doing it more times, increasing the frequency, is what I would call horizontal scaling, or rinse and repeating that strategy every time these prices fall out of sync. So that's what arbitrage is. Now, you can do arbitrage in a traditional financial setting. You could arbitrage on traditional exchanges. You could do it with cryptocurrency on traditional cryptocurrency exchanges like Binance or Coinbase, for example. People talk about these as centralized exchanges. But the problem with that is by the time that you move cryptocurrency from one exchange to another, the price can move on you. And then there is risk of losing money. All right. So if you want to arbitrage in that way, you could lose money because the price could fall, and then that's no good. But this strategy uses decentralized exchanges, okay, which are very different. So decentralized exchanges are cryptocurrency exchanges powered by smart contracts on the blockchain. So in the case that we're talking about with this bot, it interfaces with Ethereum-based exchanges. So smart contract-based exchanges on the Ethereum blockchain. So there's examples like Uniswap, Kyber Network. We're talking about several in this presentation. I'll show you later in this bot. Okay, so these exchanges are powered by smart contracts, which basically means that you can hook in. They're public interfaces. So anybody can plug into these and create their own smart contracts that talk to them, and then you can take advantage of these arbitrage opportunities by writing your own smart contracts. And it's a contract that the trade will be successful. And if the trade is not successful, then it won't execute. Okay, that's the beauty. So with decentralized exchanges, you completely eliminate the risk of the price moving on you, because you're always talking about the price instantly on the blockchain whenever you make the trade. And so if we're going back to this thing of it's $101, $100 here, $101 here, then basically the smart contract is going to detect this, and it's going to buy it and sell it, and the price can't move while the smart contract is making this operation, because the blockchain only processes one transaction at a time. Okay, so that's the beauty of decentralized exchanges powered by smart contracts. You can write your own smart contract to hook into them. You can do arbitrages where the price won't move, and it totally removes the risk. So now, what's even better is you don't even have to own the cryptocurrency that you're arbitraging whenever you perform this strategy. That's pretty crazy. So how can you do that? Well, that's with flash loans. Okay, so this is where you can literally borrow millions of dollars in cryptocurrency as long as you pay it back in the same transaction. So what does that mean? Well, basically, there are lending pools that have millions of dollars in cryptocurrency in them that you can tap into, and you can borrow all that money to do these arbitrage trades, okay? And you can borrow all of it with zero money down, all right? So let's say you wanted to exploit this price difference, and you wanted to do it with $1 million worth of Ether, or not necessarily Ether, because it'd be, let's say, wrapped Ether, right? WETH. So let's say you wanted to borrow $1 million worth of WETH and exploit this price difference, assuming there was $1 million of depth and liquidity, then you could do that. And then you don't even have to have the $1 million. You could exploit that difference, take the profit, and then pay back the flash loan in the same transaction while you're creating the smart contract, okay? So that's the beauty of flash loans. This is a brand new technique. This is one of the most cutting edge things that honestly I've ever seen, and it's only made possible by blockchain technology. Okay, so we're going to use DYDX tonight for our flash loan provider. So I'll show you that DYDX. We'll go over that more later when we talk about the code. But DYDX is a trading platform, and they provide flash loans. And I'm using DYDX because they have the lowest fees. All right. So that's a high level overview of how the bot works just from a strategy perspective. That's how it actually makes profit. But let's talk about a brief introduction to the architecture. So let's see, I got a quick question here. Is there any case where you can owe money to the loan if you make less? So in that case, basically the trade just would not execute, but the bot basically tries to guarantee that the trade is profitable before it even attempts the trade. So I'll talk about that in a minute. Yeah, when you make a flash loan, like you can't lose the money that you're borrowing. So like you can't be liable for that. To which extent is arbitrage profitability affected by how many people already do arbitrage? So it is affected by how many people do it. It is zero sum in that sense, but I'll talk about that more later. There's still opportunities out there for sure. I'll talk about how to do them. Deploying smart contracts with truffle maintenance pricing. We're not going to use truffle. I'll show you later. All right, so let's keep going here. Unless there's any super important questions, we'll save some more questions for later. So let's talk about the basic structure of the bot. So it's got two sides. So it's got a smart contract. And this is a giant smart contract that facilitates all of the trading logic. It talks to each decentralized exchange. It gets the flash loan. It executes the trade and the arbitrage between the two exchanges. All right. And then there is an app, basically. It's a price bot. And what this does is it fetches the cryptocurrency prices on each exchange. It compares them, and it's constantly looking for opportunities. And whenever it finds an opportunity, then it will fire a transaction to the smart contract and execute the trade. So there's two parts to this app. There's a smart contract on the blockchain, and then there's a price bot, which is an app that you'll just run on your computer or on a server if you want to. And it will talk to the blockchain. It'll fetch information from the blockchain. It'll look at the prices, and it'll execute a transact on the smart contract if it finds a profitable arbitrage. Okay. So, yeah, and the cool thing about this smart contract is the trade will fail if it's not profitable. So that's one of the cool things about, like, you can't lose money. And this price bot will also look for profitable trades before it tries to trigger this transaction. All right, so nowadays ETH transactions are taking a lot of time in order to perform a transaction on ETH network, 1 to 2 minutes. It's just you got to use a higher gas price if you want it to go faster. Can you lose gas fees if the contract does not go through? So yes, you can. So that's what I was saying earlier, is there is a tiny risk, well, not tiny, but there is some risk of, like, you could, if you don't pay enough gas and your transaction doesn't go through, or the trade is wrong, then you can't recover those funds that you lose on attempting the trade. But I'll show you how to, like, minimize the likelihood of that happening. Basically, you just need to make sure you're paying high. You need to have high enough gas price. You need to make sure your trades are right, and I'll show you how to really customize that in the bot. That way, you won't lose money. Okay. All right. Let's keep going here. So let's talk about, flash loans. I talked about how basically, like, you can borrow, millions of dollars in cryptocurrency at a time. But what if you don't need to do that, right? Like, it's cool that you can borrow that much. Think about, like, a line of credit where you can borrow millions of dollars, but you don't always need to, right? Like, sometimes it's hard to find flash loan transactions where you can actually use that much money profitably. So sometimes you can just do smaller flash loans. So smaller flash loans might be a few $1,000s, or maybe like $10,000 or something like that, to make a trade, and you make a small profit off that, right? So I'll show you an example. Like, this is an example right here. It's one of the examples I shared inside the program. So basically, like, this is a flash loan for USD coin. It ARBs synthetics token, all right, back to USDC coin. And basically has about a $35 profit. All right. And you can see even with the transaction fee, even with that high gas fees right now, I know the gas fees on Ethereum are crazy right now, but it's profitable even with that. Okay. So now you might say, oh, $35. Okay, cool. Like who cares? But $35 profit, you think about it the wrong way. It's not just about doing it one time and making $35. Like what if you could do it, 10 times per day? What if you could do it, 100 times per day? What if you could do it 1,000 times per day? All right. So, and that's the whole idea of horizontal scale that I was talking about. Like if you could take smaller profits and do it over and over and over again, like why wouldn't you just do that? Right. So that's the whole idea here. So you'll see that more clearly here in a minute. All right. So yeah, that's the strategy that we use here. And so like, this is totally possible. And one thing that I would say is basically like creating your own strategy is the key to success with this, right? And the key to success in my experience, right? How I have done this successfully is basically like not trying to compete with other people. So somebody asked a minute ago, like the sense that the whole idea that like the more people know about arbitrage, the less profitable it is. That's true, but I think it fails to recognize like how big the pie is, right? Like there's billions and billions and billions of dollars getting traded on decentralized cryptocurrency exchanges. Uniswap alone has like, I think it's like 10,000 pairs. It's something crazy like that, right? And then there's multiple cryptocurrency exchanges popping up all the time. Like it seems like several new exchanges every single month, several new cryptocurrencies every single week. All right. So you just multiply that out. Like the opportunities get bigger and bigger. Like there's just more opportunities out there. Okay. So I'll show you how to create your own strategy later. But the whole idea for me is creating strategies that other people aren't using. All right. Because if you want to take those like $1 million flash loans out that I was talking about, like you're going to be competing probably with some of the most sophisticated developers in this space. Okay. So they're incredibly smart. They know how to tune their bots to like get ahead of you on the trades. And it's going to be hard to outrun them. Okay. So you can, but it basically involves like running your own Ethereum node that's really fast, like maybe even running multiple Ethereum nodes in different places. Basically like tuning your bot for speed, paying really high gas prices to get in the front of a trade. And that's kind of risky because you might lose money, right? With somebody else front running your trade, and then you might pay a lot of money, and that's riskier. So my personal experience, I've had the most success, like not trying to go to the major watering holes where everybody's like trying to compete and just doing something else. So I'm going to show you a strategy like that today. I'm going to show you how to customize it for yourself. All right. So let's just monitor here. I would assume if you borrowed $1 million, it would take a long time to trade that much. Not necessarily. All right, so let's see here. All right, let's keep going with the presentation here. All right, so yeah, so like for example, like when I talk about the most popular pools, like you'll see most popular strategies. Basically, like a lot of people are doing this, where it's like they take Uniswap. And then they take like, Kyber network, for example, and they take like some of those popular pairs and they try to like arb the liquidity pools on Uniswap and Kyber. But the problem is there's a lot of people that are also watching those two things. So basically like liquidity pools are basically where people just park their money. All right. And then they're able to do it on Kyber and Uniswap. And then they basically say like whenever the prices fall to sink, they try to arb those pools that have like $1 million worth of funds in there. So I'll show you an example. Like so let's pull up Uniswap. And then you can see like, Uniswap's got almost $2 billion worth of liquidity in it. And so somebody looks at like the the DAI pool, it's got $154 million. So that's a $154 million honeypot. And I guarantee you there's like, some of the smartest developers in the world are looking at that liquidity pool, waiting for it to fall out of sync so they can arb it, right? So I would not personally do that if I were you. I don't do that because it's going to be really competitive. Yeah, liquidity pools basically have to do with automated market makers. That's how it works. Basically, like when somebody comes to Uniswap and they buy, whenever they buy tokens, basically these top pairs, there's pairs inside the liquidity pool, and it like moves tokens around to determine the price. And actually, my example earlier was not good. I was talking about the DAI volume. I should really be talking about these pools right here, right? So like the ETH DAI pair, for example. Okay, so let's keep going here. So instead of doing this, like I'm gonna show you a different way, right? So we're talking about like smaller, more profitable, like smaller, more frequent trades. You don't have to like arb liquidity pools. So like some exchanges, some decentralized exchanges actually have like order books. So Radar Relay is an example. So here's like a ETH DAI pair that actually has an order book, and you can see that this is like a $1,400 order. All right, so it's not like $1 million order, but you could potentially arb this, okay, and fill this order basically with a flash loan, and then if you're able to fill this order, you could dump it on something like Uniswap, for example, and then make a smaller profit off of that rather than trying to like arb this massive pool that everybody else is watching. So that's an example. So that's kind of the strategy I'm going to show you tonight. So we're not going to use Radar Relay per se. Radar Relay is just an example of a decentralized exchange that supports limit orders. And you could apply this strategy to any of the exchanges that have limit orders. 1inch Exchange has limit orders, et cetera, et cetera. But one of the reasons I bring up Radar Relay is to give you this visual example of this traditional order book, but also because they use 0x. All right, so 0x is a decentralized exchange protocol. All right, it's a network of decentralized exchanges that it basically powers a bunch of different decentralized exchanges. And so what I'm going to show you tonight is actually fetch data from these 0x order books and basically like sift through the orders and see if you can arb one of these orders on a decentralized exchange that actually has liquidity pools, like Uniswap, for example. But instead of using Uniswap, we're actually going to use 1inch Exchange because it basically allows you to tap into the liquidity of a bunch of different cryptocurrency exchanges. So you don't have to like wonder if Uniswap's got the liquidity. If any of these dexes have the liquidity for the price discrepancy, then it's much more likely that you'll find an arb, basically. All right, so that's an example. So that's what we're going to focus on. So let's see here. All right, so let's start with that. So what we're going to do is create a strategy where we can fill a 0x order and try to arb it on something like 1inch, for example, okay? So let me talk about how 0x works. So 0x is it's a decentralized exchange protocol. So 0x stores all the orders off chain, which basically means they're not on the blockchain. What happens is somebody basically signs their order with their intent to trade and puts it in the 0x order book, which is powered by an API. So what we're going to do is actually talk to this API. So if you're not really much of a developer, explain basically an API is just like it's like a website without a website, a website without a user interface. Basically, it's a server with a database inside of it that stores everybody's orders. And you can communicate with this API directly without a web browser like this, but you actually can make web requests to it, like with another app. and pull the data from it. So that's what we're going to do. We're making a web request to the 0x API to fetch back the this particular order book. So the WETH die order book. So it's much more than this. These are just the orders on Radar Relay, but the entire WETH die order book on the entire 0x network is going to be much bigger than this. Okay. So yeah, that's what we're going to do. And here's the API specification here. You can see basically when you want to fetch an order book, then you just give it the two different cryptocurrencies. So in this case, we're going to look for WETH and DAI. All right. And then you can just get back all the orders that contain, WETH and DAI. And like, here's an example. So I'll show you this live in action right now. I'm going to do the Postman app. All right. So Postman lets you make web requests with a nice looking UI here. So I'll show you an example of this. We can click send and boom, there we go. So this is like the web request to the 0x API for the WETH DAI pair. Okay. And it returns the different orders. So here they are. I know this might look like kind of gibberish, but I'll go over like briefly what this is. Basically, like all you got to really care about are the individual orders. And then these. Basically, the maker is the person who created the order and put it in the order book. You're going to be the taker in this case. Okay. And the maker asset amount basically is the amount of cryptocurrency that they want to give. All right. So in this case, it's going to be WETH. And then the taker asset amount is going to be the amount that you give. So in this case, DAI. And then basically the maker asset data is just the address of the token, and the taker is the address of the token. So that's the whole idea. All right. So you're gonna get that data back for all these different cryptocurrency pairs, and then we'll just like go through that entire order book and see if there's any profitable orders that we can just take them and look one by one on the different exchange. So like I said, we're gonna look at 1inch. So I'll pull this up here. Sorry, I'm pulling up the. All right, so here's the smart contract for 1inch. Actually, that's not right. Hold on. Let's see here. Sorry, I'm pulling up the smart contract. Let's see here. All right, I think this is it. All right, so here you go. Basically, let's go to read contract. Let's see, where's the implementation? Okay, this is not it. Don't worry about that. Basically, the idea is that there's a function on there that will allow you to check, whether the order is profitable, and that's what we'll call. That's what we'll call for whenever we like check the profitability of the order. You'll see it in the code here in a minute. And if you're in the membership program, I did a video last week where I kind of like did some manual testing where like you can take this information and like chop it up and put it into the smart contract to determine the profitability. So go check out that video if you haven't already. But it works as is inside the code. So really quick question. Somebody says, how do you find smart contract addresses for specific exchanges? That's a good question. So there's not always a good, reliable, like central place for all the information. Sometimes you just have to do some digging, like looking on Google, so maybe going to the website where the exchange is. And then like sometimes they have their smart contract addresses pasted there, all that kind of stuff. All right. So let's keep going here. All right, so yeah, our bot is going to use the WETH DAI pair. All right, so this is nice and straightforward. It's a good one to start with for lots of reasons. I'm gonna just show you these two cryptocurrencies. I'm sorry here. Yeah, so WETH and DAI. So WETH is just wrapped Ether, okay? So basically, like Ethereum, the native cryptocurrency in the Ethereum blockchain is Ether, okay? So like ETH is, it's not an ERC20 token. It's just a currency that runs on the blockchain. So when you trade other tokens, like on Uniswap, for example, and you're going to do it with like arbitrages, you want it to be an ERC20 token because you need to be able to like call the transfer function and like transfer from and like approval and all that kind of stuff. It's got to work like an ERC20 token. So basically you can wrap your Ether and like put it into an ERC20 token form. So that's what WETH is. And the WETH contract, you can do it really easily. You can just like send your ETH to it and it'll wrap it for you. And so the other one is DAI. So DAI is a stable cryptocurrency whose price doesn't change. It's a decentralized stable coin. And so basically we're going to be checking the Ethereum to US dollar price. Kind of. All right. Because DAI isn't exactly $1 and WETH isn't always exactly the same price as Ethereum or Ether. But that's the idea. And WETH and DAI are both compatible with a flash loan provider, so that's one big advantage. Okay, so yeah, and so WETH and DAI are both ERC20 tokens. They both are powered by smart contracts, and therefore they can be traded with these smart contracts to make this bot work. All right, so let's go ahead and set it up. So like I said, if you're following along with the video, I wouldn't necessarily recommend trying to do everything step by step as I'm going through this the first time. You might want to like watch along with the replay later because it might be kind of challenging to do it that fast. So, but I will walk you through the setup steps and you'll have everything here inside this video so that you can follow along later. So let's see here. So yeah, there's a link down below to the code. So if you're watching like on the page, like you can just click through the YouTube video. It's in the video description. If there is, let me just see here. Yeah, it should be in the video description. So if you're watching this on the replay, wherever you are, if you got this from email, then it should be in the email you received. If you're watching it inside the video vault of the membership, then it should be, if you're on the replay, then the code should be in the description below as well. All right, so yeah, once you have the code, there's a zip file, download that, extract that, okay? And so once you do that, you should open it and try your text editor, and you'll see something that looks like this, all right? So yeah, there's we talked about the bot being two different parts. It's got an app basically that looks for price discrepancies and then like executes the trades, and then it's got a smart contract. Okay, so we'll start with the smart contract. So you see the tradingbot.sol right here. So this is the Ethereum smart contract that's going to go on the blockchain. So basically, you'll take this. All right, you can kind of look through here. I won't explain all the code just yet, but I know this looks kind of long, looks a little bit scary maybe if you're brand new to coding, but it's a complete solution. So like, you could like not have to worry about this. Like you could just set this up, right? Not necessarily change it. Now you can change it, of course, if you want to implement more of your own strategies. So, but basically the first step is to take all this, all right, copy it. And then you'll want to go to Remix. So remix.ethereum.org is the online Solidity IDE. Okay. In order to like compile this and deploy it, so you want to paste it into Remix, and of course you want to create a new file here on the left-hand side. All right, create a new file called tradingbot.sol. Paste in your code here. All right. Somebody says, can you make a GUI or a GUI for that bot? Yeah, you can, for sure. So you'll paste that in there. And then, let's see here. You'll want to make sure that you have MetaMask installed. So sorry, I know it's kind of basic. I assume a lot of people already have that done, but I know not necessarily everybody is up on that step. So let me just cover that real quickly. There's a lot of different like skill levels that are watching this presentation tonight. Some people are not too much, like haven't gotten that far in their journey in blockchain yet. That's totally fine. So I want to make sure I cover the basics in case I miss out on something. So yeah, the first thing is you need the MetaMask extension for Google Chrome. Okay, so just like Google MetaMask Chrome. All right, that's what I just did off screen, and you'll find the MetaMask extension here. Just click install. Okay, and it will you'll see this little fox icon in your upper right hand corner. Okay, and so you need an account with some Ether in it. All right, so that's the next thing is you need some Ethereum cryptocurrency to pay the gas fees. And so you can do that on a website like Coinbase, for example. If you don't know how to buy cryptocurrency, you can just look on Coinbase. And you need to buy some Ethereum. So I mean, maybe you can start with like $100 or something like that just to get started. And then you'll need to fund your account, okay? And now mind you, you need a special account for this trading bot. So I highly recommend creating a new Ethereum account specifically for your bot and funding that with cryptocurrency for a couple of reasons. Like one is that this private key for your bot is going to live inside the bot code, and you don't want to store other money inside that in case that account ever gets compromised, okay? Like you don't want to store other tokens. You don't want to store other cryptocurrency in there because like, let's say like you put your bot on a server somewhere and that account got compromised, then, you can lose your money, right? It's just a security risk. Don't do it. So you can create a new account in MetaMask. It's pretty easy. You can just go up there and create a new one. Use that specifically for your bot, okay? The other reason is like if you have a profitable cryptocurrency bot, you don't want somebody else copying your trades. So you want to keep the account activity separate. So like if you have a public wallet, like don't send like Ethereum cryptocurrency from your public wallet to your bot wallet, like do it from an exchange. Because the thing, like somebody asked earlier, like if you have like what, if more people know about it, like is it like not profitable anymore? It's like, no, there's lots of opportunities, but you don't like, if you spend the time to find an opportunity, you don't want to just like give it away to somebody else. So let's look here. So make sure you have some Ethereum cryptocurrency in your wallet with MetaMask, all right? And then you specifically need MetaMask because you need that to deploy the smart contract in Remix, all right? So let's see here. All right, so yeah. Paste the trading bot inside here, create a new file called trading bot. We're going to compile it. So go to the compile step. That's this little Solidity icon. If you don't have that, you don't see it in Remix, you can go to the plugins here and search for like compile, Solidity compiler. You click activate. Mine says deactivate because I already have it. And you also want the deploy. All right, deploy and run transactions, click activate. So you may not see them here whenever you load Remix the first time, but you can just load them up here. All right, so anyways, compile. And then I'm going to use Solidity compiler 0.5.17. I think that's the one. Let's see here. I click compile. And then boom, there you go. All right, so it's got some warnings here. That's okay. It's because we're using this experimental ABI encoder. Don't worry about that warning. It's required for it's required for some of this code. It's not a big deal. So next, we're going to deploy it. So you'll want to click the injected Web3 provider, okay? And then you want to make sure that you're connected to the Ethereum mainnet, all right? So now this is going to cost real Ethereum cryptocurrency to put this on the network, all right? So you'll probably want to wait for gas fees. So somebody says, why 0.5.17? Because that's the one that this correctly compiles with all the features of Solidity inside of here. So you'll probably want to wait for the gas fees to come down before you deploy this. Like, you don't want to necessarily deploy it when the gas is 400. So let's just see. Let's say right now the gas is only like 88 Gwei, so that's actually pretty good. Pretty good in the grand scheme of things. It's not like 500. Okay. So anyways, you'll want to click deploy. All right. And so there you go. All right. You'll, it's not too bad right now with the max gas. Actually, so sorry. Before you do that, you want to click trading bot. So that was 0.3 Ether. Someone was asking how much it was. So let's see here. So anyways, you click do trading bot, and then here's the next thing. So let's talk about flash loan fees, because you have to pay fees, and so your smart contract needs WETH. So when we're going to do the flash loan, we're going to borrow WETH. All right, and so whenever we get the flash loan from DYDX, remember that's the protocol we're using. We're getting the flash loan from DYDX. Anytime we borrow money, we have to pay a fee, but it's really, really, really small. Okay, so whenever we borrow WETH, WETH is divisible by 18 decimal places. So like 0, 0, 0, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's the fee. All right, so it's like way less than a fraction of a penny. All right, so this is the fee every time we take out a flash loan. It's like it's really, really, really tiny. It doesn't matter how much we borrow, it's always this amount. Okay, so we need some WETH in our smart contract though in order to pay these fees. So like you can send some Ether to the smart contract when you deploy it. So if you look at Wei, you could just do 100 Wei, and that would fund your smart contract enough to do 100 flash loans. Does that make sense? So basically, like 100 Wei would be 100 transactions worth this much. Okay, because that's the Wei value. So if you wanted more, if you want to do a bazillion, then you just got to multiply that number by the amount. Now the whole idea of this bot is it's going to accumulate more WETH. So like you shouldn't have to refund this, but you could always send more WETH to it if you ran out for some reason. So the reason we can send value here with Ether from our wallet is because in the deployment step, I'll talk about this when we go through the code. Basically, what it does is it gets WETH. So basically it takes the value that you sent in with the transaction when you deploy it, and it turns that into WETH and assigns it to the smart contract. So somebody says, once you deploy smart contract, you don't need to deploy ever again. No, once it's on the blockchain, it's there forever. Unless you want to change it, then you got to redeploy it, a new copy. So somebody says the small fixed DYDX has the best fees. Basically, Aave has 0.9%. So if you took out $1 million flash loan, it's going to cost you $9,000 or $900. I can't do the math off the top of my head. I'm kind of tired. Let's actually look. Oops. Yeah, $9,000. I was right the first time. I had to second guess myself. All right, so let's keep going. So that's what you'll do. You'll do that. You'll click deploy. All right, and then you'll click confirm. All right, so I'm not gonna deploy right now, but I do have a copy of a deployed smart contract here. So this is what you can do: is you can look for what once you deployed it and you've got a confirmation here. You'll click OK, and then you'll see these functions here. All right. You can just, it'll show you the different functions you can call. So you don't need to call them in Remix necessarily. And that's the other thing is if you want to basically look for a new smart contract, then you can, or if you want to like recall your smart contract after you deployed it and look at it in Remix, then you can just like paste in the address here and load it here. That's what I've just done. Okay. So like if you want to send more WETH later, you can do it with this interface. And you want to withdraw tokens, like after you made profit, then you can like withdraw tokens. I'll talk about that here in a minute. Somebody says if the gas fees are more than your wallet has, a transaction won't go through. That is correct. All right, so let's go over some of this code, and then we'll actually let's go back to the code review. Let's just say you don't want to do much developing and you just want to run the bot. Let's just do the setup, finish the setup, then we'll go through the code examples. So yeah, let's go back to that. That's the first step, is getting the smart contract to work. All right. And so next, what you want to do is set up the rest of the app. So now let's talk about setting up the bot. So the first thing you want to do is set up your environment. So this thing is you'll see this .env.example file, okay? So this is where you want to add the settings to your bot, okay? So let's go through these one by one. Let's start with the RPC URL. Actually, first of all, what you want to do is duplicate this file. So this is .env.example. So you want to click like duplicate. And then you'll basically want to create a new file just called .env. All right, so I've already done this. I'm not going to show my .env file in here because it has my real sensitive data in it. You don't want to ever show anybody else the data inside your .env file, but that's what you'll do. You'll duplicate this .env.example and just create a .env. All right. So that's what you'll do. Okay. And then you'll fill out the variables with the real values inside the .env file rather than the .env example. So you won't actually use the .env example. You'll use the .env file. I'm not going to show mine, but I'm going to show you how to customize it. Okay. So no, it is not the same code as the other trading bot. Somebody asked. This is a custom bot, it's different from the stop loss bot. This is much more advanced, much more sophisticated. So let's start with the RPC URL. So this is your URL to an Ethereum node. So in order to make your bot talk to the blockchain, it has to talk to an Ethereum node. All right, so you can get one for free with Infura. All right. So Infura is an Ethereum node as a service. All right, so basically you don't have to run your own Ethereum node. You can if you want to, and you want to like make this bot more sophisticated. You can definitely run your own Ethereum node. I highly recommend Geth or Parity to do that. But if you want to just get started today without the hassle of doing that, then you can use Infura. Okay, just click sign up. All right, go through the setup steps and create a new app. All right, and once you've done that, your app will give you a RPC URL to the main net. That's what you want to do, the main Ethereum network. That's how you make this bot actually work. And then you paste in your API key. So once you've duplicated your .env example file, paste in your actual API key there. Okay, right there, boom. So the next thing will be your address. All right, so what you want to do is actually get your MetaMask address, okay? So you want to like copy this, boom, and then, put it inside of here. You'll do the same thing for your private key. So if you like go to your account, I don't want to step through all the settings on my MetaMask account live because I don't want to accidentally show a private key, but you can just look up how to like reveal your private key on MetaMask. All right. You want to copy that and you'll paste it inside of here. And then next you'll want to get the smart contract address for your trading bot. So basically you can just like copy this. If you go back to Remix, click this little copy button. You can copy that address and then put it here for the contract address. And then next you want to, you could just start with these default settings if you wanted to, but I wouldn't touch this estimated gas. That's the estimated gas for the actual trading function, but you can update this gas price. So somebody says there a GitHub link, you prefer Git. So for this particular masterclass, the zip file has all this information. So it's the same, it's literally the same thing as GitHub. So I just like clicked the GitHub download zip and just produced it that way. That way the code's not public and I don't have to add everybody to a private repository, because I want to make this only for the people in the membership and the people who signed up for the masterclass. So let's see here. So I wouldn't worry about the gas limit or the estimated gas, but you can update this gas price. So if you look at ETH gas station, you can change this to the current gas price. So I had this set on 200 when I was testing this before, but you could like update it to like, if it says 88 here in traders, 94, if you want to be extra careful, I would do like, I'd go higher than 94, maybe do like 100. Okay. All right. So that's what I would do. I would look at the ETH gas station price and then go a little bit higher, because you want to make sure that it actually works. Okay. So that's how you fill out each of those. Again, you want to copy this file, create an actual .env file, because you don't want to, you want to actually work. Somebody says, what's the gas limit, the gas price? That's the gas limit and the gas price for the actual trading transaction. I wouldn't mess with those right now. You can later if you want to, but I'll show you, I'll point that out in the code. So the smart contract posted to the blockchain, they can start accepting dynamic data from like PHP. Yes, that's correct. So somebody says, is the .env in the code? It's not. So you have to create your own .env file, and you can use the .env.example to create your own. Estimated gas is just the estimated gas for the gas cost of the trading transaction. All right, so let's continue with the bot setup. So basically, like, you'll need to run this with a terminal. So if you're not a huge coder, that's okay. You don't have to be like a hardcore sophisticated coder to do this. I can show you literally how to set it up. Now, of course, some coding knowledge is going to help if you want to customize this. But if you want to just run it as is, you can. So let's see, like, so really quickly, you want Node.js installed, so you can go download the latest version of Node.js is probably fine. I'm using version 9.10.0, but I think this version will work. So you can just click download. You can also install it with a package manager like Homebrew, and you can see if it's installed by going to your terminal and typing node-v. All right. So I'm using 9.10.0. All right. So you need Node installed. Let's just see what else. Yeah, that's the only real like system dependency. So once you've downloaded the code, you open the file in your terminal. Okay, you want to do npm install. All right, because that's going to install all the packages on your machine. All right, so I'm not going to actually do this. I've done it before. So that's going to install all the dependencies that you need for running the bot. You can see them all listed there inside that package.json file. It's all the dependencies inside there. Boom. All right. And then, let's see here. Yeah, once you've got your .env set up, you can just do npm run start, and then boom, you'll hear a ding, and it's gonna start checking the order books. You can see it's checking the thing. Yeah, it's okay. So you'll probably see this the first time. So basically, like, that's what it's doing. It already loads it up. You'll hear the ding happen. That means the app has started, and it's already like fetching the market data. All right. And then it says, boom, has a fee. So I'm currently skipping orders that have fees and actually logged at the console. You'll see that. But whenever you actually see a profitable trade here, you'll see like this. And this looks kind of similar to the price bot you guys might have seen in the other tutorial, but this is like actually much more sophisticated. So whenever it finds it, it'll try to make the trade. And the first time I did it, it blew up. That's okay. That's because I don't really have any funds in the particular wallet that I am have in my .env file. That's okay. I don't have like a real account inside there. So you guys might see that same type of situation. But I'll show you how to eliminate that. So the whole idea is here is it'll run this. You'll click npm run start, and it'll just sit there and wait and look for trades, and whenever it finds one to execute, like, it'll do that, right? And it'll keep like polling and logging until it finds one. So this is a let's just see here. This is too small of a profit for it to be profitable. So we'll up that here in a second. Don't worry. But yeah, that's how you start it. That's pretty simple. So it's literally like NPM run start, boom, your bot's running for this particular pair. Now you can certainly customize this to look for different pairs. And then you just stop it by just doing like Control C. So let's look at the code and see how it works, okay? Let me just double check. All right. Somebody says, is there a way to make the gas prices dynamic? Yeah, you can use ETH Gas Station's API to do that. So if you are a coder and you want to like make this more dynamic and more sophisticated, you can totally customize this. But this bot will definitely get you started. All right, so let's look at the code. Let's start off with the smart contract, okay? So we'll do some code review here to show you how everything works. I'll show you how to customize it, and then we'll move on to Q&A. Somebody said, how can I deploy it on mainnet? So yeah, the smart contract's already on mainnet. So if you're asking about the bot on a server, you want to use something like AWS, for example, or you could just use Heroku. That's what I like to use. It's pretty easy. All right, so let's go through the smart contract code. So here at the bottom, if you go like online, 199, that's where the actual contract for the trading bot starts. So everything above that, they're all libraries, okay? So basically, like at the top, this is just a library for the flash loans, basically. It uses this interface of structs. You can just even minimize that. It's all for DYDX. So DYDX is the flash loan provider, all right? We have an interface for ERC20 tokens. Interfaces are basically just like libraries of smart contracts, all that kind of stuff, right? So here's a DYDX flash loan. This is the DYDX pool. I'm just going to minimize these. One split is the interface for 1-inch exchange. All right. Remember I said that we're going to arb between 0x and 1-inch exchange. So here's the, there's two functions on this. There's get expected return. That's when you can like ask the exchange if there's you can see what the return rate's going to be. Get expected return, and then here's the swap function. That's where you actually like make a trade, and then you like put the contents of it to do the arbitrage. Okay. So let's step through the trading bot code. So first, this is the constructor. This is like what happens whenever you deploy the smart contract. Let me just bump the font up here so you can see a little better. So this gets ETH. So like I showed you earlier, whenever you deploy it, any ether that you send to it, it turns it into ETH. So there's this get ETH function down here. All right, this is it right here. Basically just calls the ETH contract. All right. And then it approves the ETH. So ERC20 tokens must be approved in order for you to spend them. That's what happens here. You can see the approve ETH function right here. So it just looks for ETH, calls approve. And what it does is it approves the 0x staking proxy. So without getting like too in-depth into the details here, so the staking proxy is basically the fee collector for 0x. So you have to basically like pay the fees in ETH. All right, so if you see this example right here, like this is a fee paid in ETH, right? So you don't have to pay it in ETH, but that's how we're going to do it in this tutorial. So somebody says, is this code specific for each exchange, or can you use the same code for other exchanges? So this is specific to these exchanges in particular, but you could change this to support other exchanges. So yeah, that's what's in the constructor. And then basically it sets the owner as the person who deployed it. So your account in MetaMask is now going to be the owner of this smart contract, and you're going to be the only person that can call the functions on this smart contract, because you don't want somebody else just like randomly using your arbitrage smart contract. Okay. So you can see this modifier here, only owner, that's you. You see the addresses up here. This is for the 0x exchange, the staking proxy that I talked about earlier, the ERC20 proxy, and then the exchange address. Same thing for one split. So one split is the same thing as 1-inch exchange. Here's the address for it. Here's like these are some constants that they use for trading. Don't worry about those. It's just some values they need for their function. Okay. And then of course the owner. and then the loan for the flash loan. Okay. So those are the variables in the constructor. So here's the main function, honestly. It's just this get flash loan. So this has all the parameters that you need. So here's the token that you want to get the flash loan for. Here's the amount that you want to get the flash loan for. Here's the token you want to arbitrage. Here's the data for the 0x order. Here's the minimum amount that you want to get back from 1-inch exchange. And then here's the distribution on 1-inch exchange, which you'll see later in the code. So basically, like, in the WETH to DAI pair, the flash token will be WETH. The flash amount will be however much you need to do the ARB. I'm pretty sure there's just like a constant value in the code. So it's like it's $100,000 every time or something like that. So you put in like $100,000 here. The ARB token would be DAI. All right, this would just be the address for the DAI token. The 0x data is just the raw data for the 0x order, which the bot actually compiles that down. I'll show you that in the code. The 1-inch min return is also generated by the code. That's the minimum amount you want to get back from 1-inch. And then finally, the 1-inch distribution. All right. So basically what it does is it calls this flash loan function, which is defined up here in the DYDX flash loan. Okay, you can see flash loan is here. Boom. And then let's see here. Excuse me. Yeah, and then your contract has to do this call function. And so call function is what gets called after you call flash loan, okay? So this data is, it ABI encodes all your function parameters and sends it into the flash loan. So your smart contract has to implement this call function in order to receive a flash loan from DYDX. So this is an expectation that UX needs for you to do your code. So here's the loan when you get it, all right? And then you can decode all the variables that you passed in whenever you did, get flash loan. And so you can see your balance of your ERC20 after you've gotten the loan, okay? And then now you can actually do the arbitrage. And so that's where you basically perform this trade. So once you have the flash loan, you get the starting balance, all right? You perform the trade. You actually I'll go through the trade in a minute. Once the trade's done, you track the ending balance and you make sure that the ending balance is greater than the starting balance. Because if it's not, then a successful arbitrage didn't happen. And so if it is, you've done it. Yeah, and if not, if it's profitable, then it'll succeed. If it's not profitable, then it'll fail. That's what I was talking about earlier. So let's go through the trading function here. The trade, here's the from token, the to token, from amount, the 0x information, and the 1 split information. So basically, it just like tracks the balance before. It performs the trade on 0x. It checks the balance after. It takes that balance and then swaps it on a 1-inch. So there's 2 functions, one for the 0x and then one for the 1-inch. So here's the 0x. Swap, basically it just approves the tokens to be swapped on 0x. Here's where it gets a little tricky. So we just give it some data to throw at the 0x contract. Here's why. So does the ARB profitability take the gas fee into account? Yes, it does. Well, it does whenever you do it in the bot. It does it on the smart contract level, but I'll show you that in the bot here in a minute. So does the flash loan amount equal the trade amount? It doesn't have to. It needs to be greater than or equal to. So whenever we do the 0x trade, we just throw a big old byte string at it. Here's why. The 0x API, like the smart contract API, the interface is so gigantic, all right? And you don't need to keep that entire thing inside your smart contract just to make a trade. So basically what I do in this strategy is just like generate all the data on the client side and then pass it into the function so that it can be called here, okay? And so then after that, after 0x has been traded, it resets the approval, and then here's the 1-inch trade. So basically it just does the approval. All right, sets up the 1 split address. It approves the tokens, and then it just calls the swap function and then passes in the right values, and then it resets approval. So it's pretty straightforward. And then, whenever you do a profitable trade, it'll look like this. So you can see the coin that was taken out. You can see the ARB sequence here. Boom, 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 boom. And you got more tokens than you started off with. Okay. Yeah, that's pretty much it. So the other important pieces of code at the bottom are when you want to take profit out. All right. You can call the withdraw token function, and then you just pass in the token address. So you just do like withdraw token here. So let's say you've ARB some WETH. You can put in the WETH address here and click transact, and it'll withdraw it. Same thing. Let's just say you accidentally had some other tokens sent to this, or you ARB some different tokens. Then you can pass in a different token address and click transact, and it'll just withdraw. Okay. So there's also a safety. So in case this smart contract receives Ether, okay, then you can withdraw Ether. So let's say you accidentally sent like 100 Ether or something to this smart contract by mistake. Then you don't have to, it's not gone forever. You can withdraw it. It's got a safety on here. All right, so that's an overview of the smart contract code. Let's move on to the actual bot code. So the bulk of this entire thing is just inside this index.js file. So this bot is just a Node.js app. It's just an Express.js app. So it's basically just a web server process that continuously runs. So that makes it really nice and easy if you want to put it on a service like Heroku, for example, because it supports Express.js out of the box. You could just like deploy it to Heroku and run it. It works as a web server. And, it's just got all these library imports at the top. You have to understand all these. Express is the main one. All right. You've got .env, so you can read this .env file. It's got this player, so you can actually make that dinging sound. You can see the player MP3 right here. Okay. And then just some other, libraries to make it work, like the Web3 library to talk to the blockchain and talk to the smart contracts. Axios for making web requests, Moment for working with times, and the numeral for like formatting numbers, and underscore or Lodash for doing like JavaScript operations. Okay. Let's make sure the stream's still good working here. All right. So we got some constants at the top, some settings, basically like always runs on port 5000. He sets up the app. Here's the Express setup. It's pretty straightforward. You don't have to change this necessarily unless you really want to. So the first thing is the Web3 config. All right, so this is your connection to the blockchain. So I got plenty of tutorials on how to use Web3. If you're not familiar with how that works, just check out any of my free tutorials on YouTube. Or if you're in the Mastery program, you can check those out as well. Or if you're in the Blockchain Bootcamp, that'll give you an in-depth understanding of how Web3J works, Web3JS works. So the next thing is the smart contracts. So you won't have to change any of this stuff. So smart contracts have ABIs, which are basically just JavaScript like representations of the smart contract, or JSON representations. They basically just describe the functions. So these are already hard coded. You don't need to change this. This is just the one split contract. So we create a Web3 version of that, just a JavaScript version of the smart contract. You need the ABI and you need the address. You have both those pieces of information here. Same thing for 0x. You have the 0x ABI and the 0x address, and you can create a Web3 version of 0x here. We have an ERC20 ABI just for doing all the generic ERC20 tokens. We've got the basically the trading bot smart contract API. I call it Trader here. It's the same thing as the other smart contract. So the contract address is coming from your .env file. Okay. So that's what process.env.contract address is. It's just the contract address variable from your .env file. Okay. And then we create a trader contract here. So somebody said, what is one split contract? That's 1 inch exchange. So you're going from 0x to 1 inch. One split is the is the contract for that. So here's also the fill order ABI. This is for 0x. You'll see that here in a minute. This is just a function, literally the fill order function on 0x. That's what we're going to use to encode that. So you see the exchanges here, 0x at 1 split. All right. So here's the assets. So die and WETH, right? And then here's the asset addresses. Here's the die address. Here's the WETH address. And of course, if you want to add more pairs, this is where you do it. All right. So we got some helpers, like some tokens, all that kind of stuff. Some utilities now, play sound. Stuff's not important. Let's go down to the bottom and work our way up. Okay. So somebody says, can I use this on a Raspberry Pi and like Debian? Yeah, you can do that for sure. All right, so let's go to the bottom. So here's like where the app like starts. Okay. So like you get on the very bottom, this is like where it just kicks everything off. So basically like what this bot does is it like loops like every few seconds and like checks the orders on 0x and it just runs through this process. It just fetches all the orders and says, hey, can I take any of these orders and can I like dump them on a different exchange? In this case, 1inch exchange. So that's what this is. Set interval is a JavaScript function that does that. It just checks, on this interval. In that case, I've set this to 3 seconds. So every 3 seconds, it's going to call this check markets function. Okay. So here's a check markets function defined right here. So basically, if it's already checking, it's going to stop doing it. Basically, if it's found a profitable arbitrage, it's going to stop doing it. That's what clear interval does here. Okay. And then it's going to like just log to the console like, hey, I'm fetching market data right now. All right. And then it's going to call this check order book function. Okay. So it's specifically checking the WETH and die order book, which I talked about earlier. Okay. So somebody says, can you show us how to test your bot? Do you put real money? Yes, I do put real money on it. You have to put real money on this for it to work. So here's the check order book function. So the base asset and then the quote asset. So that's like WETH to die. All right. So we have the addresses listed here. And then what it does is it just calls to the 0x API. This is kind of a big, long, ugly string. All right. It's not the best like coding in the world, but it's simple and it's readable, especially if you're a beginner. Like you don't have to like wonder what this means. It's a lot easier if you just read it with this string here. Okay, so like 0x API. That's the same thing I showed you earlier with Postman. Basically, if you look at this request, that's this exact same request right here from the 0x endpoint, and we just like literally just toss in the base asset address and the quote asset address. You can refactor this and like make it much nicer looking, but I really want to make this like as readable as possible, especially for beginners if they want to customize this and don't have to like, hold a bunch of different functions in their head at the same time. So what we do is we check that API, we get the bids, which is going to be the WETH to die bids. All right, and then we go through each of them and we check to see if there's an arbitrage opportunity. So we pass in the order, that's the 0x order, and that's this big JSON response here. So this individual order, you're basically passing in this JSON object right here, okay? That data is gonna go into this function, and then we give it the asset order. So we start with the base asset, which is gonna be WETH. We move to the die, which is the quote asset, and then we go back to WETH. So WETH to die to WETH is the arbitrage sequence. You start off with WETH, you fill an order, you get back die, and then you trade it again on a different exchange for WETH, and then hopefully you have more WETH than you started with. That's how it works, okay? So go to check arb function, all right? Let's see, check arb, here's the main thing, all right? So what we do here is, of course, we have some arguments. So we get the asset order. So that's, like I said, WETH to die to WETH. And then max USD amount. Actually, I don't think it's even used anymore. It's okay. Let's just see. I think that's actually not used anymore. Sorry. So all you need is 0x order and then the asset order. So you could theoretically, like, if you want to refactor this code, I'm not going to touch it right now because it's working. But if you want to refactor this, I'm pretty sure you can take these two out. I don't think you need them anymore. So you could probably just do that and it'll probably work. I'm going to leave it there just because it works. I don't want to break anything, but that's probably all you need. So asset order and 0x order. So right now, like I basically make a temporary order because I don't want to keep checking the same order over and over again. So basically I basically just keep an array of checked orders. So basically I turn it into a JSON string, and I just say like, hey, just throw it in this array. And if it's in that array, like don't keep checking it. Okay. This includes does. Okay. So, that's what this does. It keeps you from checking orders twice. So we have some rules for the orders. Like we want to keep it simple. We want to have a very simple strategy. So like we don't want to do a bunch of crazy math in here. We want a very simple, straightforward strategy just to get it to work. Right. And if you want to customize this to get more crazy, to get more sophisticated, have at it. But I want to give you like the like starter kit that will work. And then you can get more crazy from there if you want to. Okay. So somebody said this is more complex than the ARB-bot. Yeah, for sure. I mean, the ARB-bot, the one on YouTube, man, it's just a tutorial. This is a real bot that actually works. So let's see here, or the price bot. I think that's what we should talk about. So basically, so if it has a fee, we don't want to worry about it. We just skip it. All right. Same thing if it has a taker fee, we don't worry about it. Just skip it. If you want to get crazy, and then like, if you want to be competitive with other people and you want to like, customize this bot and try to figure out how to like make all the fees work, that'd be a really good thing to look at, right? Because you can get much more sophisticated. Somebody earlier asked like, hey, could you customize this to, be dynamic with gas prices, all that kind of stuff? Yes, totally. You can do that. If you want to get crazy, dig into the code, get a really good gas API, you can totally do that. Okay. So somebody says, how would you send more ETH to the bot through Remix? You just take the smart contract address and send it with your MetaMask account. So next we want to get like the input amount. So this is going to be the taker asset amount from 0x. So basically like the trading function on 0x, this is where it gets a little complicated. And you don't have to understand everything about how this works. You can just know that it works. Okay. Like, here's something called a tuple. So a tuple is basically just like a collection of arguments that get thrown in as one argument, all right, inside of a solidity function. And so basically we want to see if the order is fillable, all right? And so basically like we take all the details from the order, and we create a tuple, and then we talk to the 0x exchange, and we get the order info. That's like the method that 0x exposes for us to do that. We get the order back. And then here we basically say like, if it's been partially filled, like somebody's already filled part of the order, we want to skip it too. All right. So here's another place where you could potentially optimize it and account for those edge cases where there might be a filled order already. So we're going to skip it for now. If you want to get more advanced, you can handle those cases. So next we have the order. All right. And we want to say, can we fill this order? If we fill this order on 1 inch and we get it back, can we make a profit on it on 1 inch? So that's when we take the 1 inch data, we fetch 1 inch data, and we pass in the from token. In this case, once we've filled a WETH to DAI order, we're going to have DAI because we've taken a flash loan with WETH. We get DAI back. So from token is going to be DAI. The to token is going to be WETH, right? Because after that trade, we're going to have WETH again, all right? So somebody says the tuples and order list, the order matter. Yes, it does matter. And then the amount is going to be the amount that we get back from the order. So that's the maker asset amount. So again, there's a maker and a taker in the order. The maker was the person who created the order. You're the taker. But after you filled the order, you have the maker asset amount. So that's why you pass in the maker asset amount here. And then the output asset amount is the amount that you get back from one split. All right, so that's going to be the final amount that you get from the arbitrage. So basically you have input asset amount. This is what you start off with, all right? And then the output asset amount is what you get back after the arbitrage has happened. So it simulates the arbitrage before it actually does it, all right? And then basically we say, once you have that amount, we estimate the gas fee, all right? And then we say, is this profitable? So basically we take the output asset amount. subtract the input asset amount, and then subtract the estimated gas fee, and that is a profitable arbitrage. Okay. So then if it's profitable, so if the net profit is greater than 0, all right, then it's profitable. And then we say profitable arb found. We tell that to the bot. Then we log it to the console. That's what you saw here. Let's see here. That's what you saw here. All right. And then we play the sound. And then we call this trade function. All right, and this is where it gets a little more advanced. So basically, like you pass in the flash loan token, flash token address, the ARB token address, the order JSON, the fill amounts, and then the one split data. Okay. So in this case, we're always just going to take a flash loan out for like 10,000 WETH. All right. That's a lot. So like 10,000 WETH is I can't do the math. I don't know what the Ether price is right now. It's like 320 maybe. So basically like, 320 times 10,000. Let's see, we'll do it's $3.2 million. It's a big loan, right? So you can change this. You're never going to like need that much probably to do your actual trades, but at least like, you can make this dynamic if you want to. Again, if you want to get more advanced, you could make this the exact amount. I always just borrow more than you need to, or in this case, will, so that you have enough. And because the fee doesn't matter. The fee doesn't scale with the amount that you borrow. So anyways, the from token is the flash loan token. The from amount is the fill amount. The two tokens, the ARB token. So I'm going to factor in slippage here. So basically like slippage is basically like when there's an inefficiency in the DEX trades. So like, I mean, I'll explain it. Like basically like if you're going to trade like, let's say Ether's $320 and you want to trade it for USDC. Like if you trade one ETH, let's say there's a 1% slippage, then basically like you might get back, like $317. So like, I mean, like basically take 1% off. So I factored in some slippage here already. All right. So you could up that slippage. You could make the slippage dynamic if you wanted to, but for now, just got a basic slippage factor in there, just a default to make sure it works. Okay. So we set up the order tuple. Again, we already did this in the other function. If you want to refactor this to pass in the order tuple, you could do that, right? So there's definitely some duplication going on here. It's not perfect code, but it's still explicit, so you can see what's going on, especially if you're a beginner. So here's where we format the 0x function call. Okay. So, remember how I talked about in the smart contract code, basically like we just throw in some data. Basically like, I'll show you here. Where is it? Where was it? Yeah, the 0x swap, you can see there's like 0x exchange. We just do call, all right? It's kind of not great, but it's good because, like I said earlier, you don't want to put in the entire 0x. It makes your code lighter. So basically, like, we're just going to throw in some data for the function call, but here's where you actually like generate that function call data. So you basically say, we're going to call fill order. So there's this fill order ABI at the top, right? I showed you this right here. This is the ABI for the fill order function on 0x. So you do that, and then you pass in the arguments for that function, which is the order tuple, which you've got here. The taker asset fill amount, that's the amount that you're going to do. And then the functions, the order signature, which comes from this order right here, okay? So this data is basically just the function call for 0x, okay? So next is we get the minimum return back from 1 inch and the distribution, all right? So these are required values when you're making a trade on 1 inch. Okay, so minimum return with slippage. We do some math, and this is not great, but it's simple, especially if like you're a beginner and you're trying to figure out how this works. Basically, we convert these to big numbers. So we take the minimum return, we factor in the slippage as we multiply by this and divide by 1,000 to get like that factor in here. Okay. Somebody says, what is a signature? The signature is the order signature of the person who signed it whenever they put it in the 0x order book. And so Crypto Unico actually, did a better job of explaining it than I did. The slippage refers to the difference between the trade's expected price and the actual price of the trade. So yeah, that's good. That's better definition than what I said. All right, so then it actually does the trade on the smart contract. So here's what it is. So trader contract methods: get flash loan, passes in the flash token address, the flash amount, the ARB token address, the data for 0x, the minimum term of slippage, the distribution, which is I just get the distribution back from 1 inch. And then of course you have to call send on the transaction. So from is our MetaMask address from your ENV file. The gas is the gas limit from the .env file. And the gas price is the gas price from the .env file. And so whenever that fires, then you will, you'll see, oops, sorry, my terminal's freaking out over here. Then you'll see that right here, boom. All right, so that's an overview of the code. Again, you just run this with npm run start. It'll start looping through the prices here. You'll see fetching market data, order has taker fee. It was skipping those orders. Remember I showed you how I was skipping all that in the code. Whenever there's a fee, if you want to get more advanced, you can change that. But whenever it finds one, it'll say, is it profitable? Yes. And so looks like this was too small of a profit. So might be looking for, might need to up those profitability rules. So how can you make this safer, or not safer, but how can you make this more advanced? I've showed you lots of different ways to do it. If you want to, I'll talk about one thing here. So the bot is making some assumptions about what the actual gas price is going to be. If you want to get safer and not burn through money on, failed transactions. If you do start getting failed transactions, you want to try to figure out why. And that's one of the reasons I have the fail-safe in the bot. When it finds a profit arbitrage, the bot code just stops. It doesn't keep going. All right, now here's why. I want to make this very safe for you all. I don't want you I didn't want you to have an Ethereum wallet in your bot with thousands of dollars in cryptocurrency, and then you just just turn it on and it just starts firing away and drains all the funds from your account. So when you're starting to test this stuff, 100%, just put a really small amount of cryptocurrency on there, not more than you can afford to lose, because if let's say the transaction fails for some reason and your bot freaks out, you don't want it to just drain your wallet, right? So definitely start off with a small amount there. And that's why I say once you find a profitable ARB, stop the bot, because I don't want you to keep going. And like I said, just say you're just draining through all your wallet funds. So if you want it to just if you want to set it and forget it with this bot, you'll need to remove that rule and create some custom strategies. The reason I created this way was for your safety, right? I don't want you to sit here and just burn through all the funds in your wallet if your bot doesn't work or something. I guess if something blows up or you make a mistake or something like that. That was for your safety, okay? So you can definitely, if you want to make it more automated, long-term autopilot, then you can do that, okay? So let's talk about customization. So, we're looking at the WETH die pair. So if everybody right now turns on this bot and looks for the WETH die pair, of course, there's going to be competition for that particular pair, especially on this exchange order. And that opportunity, would be more challenging. Okay. So how can you extend it? Well, you can extend it pretty easily just by adding new pairs. Okay. You can, look for new pairs here, die and WETH. You can look for different pairs on the 0x order book. You'll just need to update the asset symbols and the asset addresses to accommodate those. You can just find the assets on Etherscan. And of course, you'll want to check those different assets here. All right. So if you want to get more advanced than that, all right, of course, I talked about you can optimize this more. Your bot can be competitive by having optimizations where you, handle these harder cases like fees, where you handle cases like partial filling and all that kind of stuff. That's a way to, be competitive and craft your own strategies. And the other would be to actually start looking at more exchanges. Okay. So, if you're going to do that, you do have to change the actual smart contract code. Okay. And it's the same true if you start taking out like obscure flash loans. You have to support different tokens from the smart contract. So basically, like, if it's going to be more advanced, start looking at more exchanges. But that's if you want to learn how to code. If you're not much of a coder now and you want to get better at doing that, then that's what the blockchain bootcamp is for. That's what the blockchain mastery program is for, to learn those skills to where you can actually customize these smart contracts. Okay. So you'll want to support more exchanges besides, maybe 1inch, for example. Maybe you want to look specifically like at different decentralized exchanges, like those strategies I talked about before. Maybe like Kyber, maybe like Uniswap, for example. Let me just listing off exchanges here, right? I talked about those being really popular pairs, but I'm just using those as an example. So you of course need to change the smart contract in order to do that. You need to change all the code honestly would be really similar. You'd need to change this function interface, but then you would need to change like how the trade function works. Basically, instead of doing a 0x swap to 1inch, you need to do like, exchange A to exchange B, and you need to import the code that, deals with those exchanges, and you would just update those right there. Okay. So that's how you would do that. So if you want to support more exchanges, you can look at like, let's see here, DeFi Prime. Let's see here. Yeah, I mean, there's all kinds of decentralized exchanges. You can just browse a big list like this. All right. You can just mine Twitter. I mean, there's new dexes popping up all the time. You know what I mean? You can also look at, let's see here, like there's scan, you gotta say Uniswap. You look at Uniswap to info and look at like any of the ERC20 tokens that are traded on here. That's going to give you a good idea of some other pairs you can look at. So, I mean, the possibilities are kind of endless at this point. Okay. So there's lots of things to look for. Okay. So I know that has gone a little bit longer than I anticipated. But there's a lot to cover here in order for you guys to get a good, overview of everything with this. So I do want to try to answer some of your questions. So I'm gonna go through the questions here in the chat. Go ahead and ask some more here. So could we do a quick mock process of deployment as quick to start here? So let's see here. Basically, like, yeah, you do exactly what I talked about. You paste the trading bot in here. You click compile. I would just rewatch the replay at this point, and then go back to that step where I talked about how to compile and deploy with Remix, and then basically you just add those values to your .env file here, and then you just install your dependencies with node npm install, and then npm run start, and boom, there you go. You're ready to go. So it says, why isn't slippage calculated in the profitability? So I think with the threshold that I had earlier, that it was not necessary. If you want to optimize it to factor in the slippage, you can do that as well. So that is an optimization you can do with the bot. You can move this slippage up a level and check for it here. So you could basically like take in the output asset amount. You could basically multiply this with slippage, and then basically do output asset amount with slippage, and then minus that. So if you want to optimize it more, you can do that. All right, let's see here. So let's see. Yeah, totally. Yeah. So is there a way to calculate estimated gas for different exchanges, for example, Uniswap? So what I would do basically is like, yeah, you can use the Web3 estimate gas function. Let's look here. Pull it up offline. Oops, sorry. So Web3 eats a contract. Basically, you can pass in the contract function and then like do estimate gas. All right. So basically, you say like contract my methods and then do estimate gas, and then it'll give you the gas estimate. And you could hard code that, or you could put that in your .env file, or you could update your code to support that. So how many pairs do I use? I use a lot of pairs. Let's see here. So what are the different pairs to try with 0x and 1 split? So I would just start looking at the 0x API, and I'll give you some hints on that one. Go look at the 0x API and start looking at those pairs. I'm gonna give you guys some homework, right? You do have some homework for this bot, but I'll definitely get you started. Adding pairs between 0x and 1 inch would not appear to need to redeploy. No, you don't have to redeploy the smart contract. Now it does have to be a pair that supports the flash zone. I'll give you that hint. Okay, so you gotta be able to you gotta be able to take out a flash zone from DYDX to support the pair. Now you don't necessarily you could make the contract more sophisticated where you swap it, but it's gonna cost more gas. So I wouldn't try that necessarily. I mean you can, but it's just, you're gonna have to pay, you got to buy a bigger ARB to support the swap function. Can I outline what to do with the index.js file to get it to work? Yeah, so basically you just need to run npm install, add everything to your .env file. So again, this is .env.example file. You need to fund your account with MetaMask. You need to add an inferior URL, put in your private key, your address, the smart contract address, update the gas, and then just do npm run start. So is the function recursive? It's not recursive. So basically yeah, you could do a quick check. Yeah, you could refactor that to make it more sophisticated if you want to make it recursive. So you probably won't want test changes. So are there any limitations to testnet? So yes, there are limitations to testnet, and that's why I wanted to do this on the mainnet, was for a couple reasons. One is that it'll just work on the mainnet, which is really nice. But yeah, there are some limitations to the testnet, which is basically like all the smart contract addresses will not be the same. So I'll tell you this much. You guys are getting so much value out of this because I've spent thousands of dollars, like literally thousands and thousands of dollars testing stuff out in prod or production, all right, on the mainnet, because not all this stuff works on test nets, okay? So all these smart contracts don't necessarily have testnet versions on the same test network. So, I've done the hard work of figuring a lot of this stuff out, putting on the main Ethereum network, using my own Ether to burn through Ether to, deploying new smart contracts, testing new things out, doing flash loans, watching transactions fail. So if you hit a little bump in the road, I've been there, I've plowed through all that stuff, spent thousands of dollars trying to get those things to work. So you don't have to. All right. So the reason I say that is because not all this stuff works on test nets. So if you're going to try to get to work on test net, you need to change all the smart contract addresses you see inside of here. And you may not actually have test net versions of those. So somebody said, I love homework. Yay. So somebody says, you said that there's a potential advantage that you're running your own node when you're running a trading bot. So yes, there are some potential advantages, especially if you're looking at different pools, because the faster your ETH node is and the faster that it picks up new blocks, the faster you can hit the arbitrage opportunities. And so like some people even think that like, some people use the strategy of running nodes on different locations, right? Like in the world. So basically like, AWS, for example, has servers in different regions. So you can do some sophisticated tests to see which of those regions pick up blocks first. I'll give you some hints on that, right? So like you can run your own nodes in different regions and see which one picks up new blocks first. And those are going to be your winning horses for like those really fast arbitrages. So that being said, that is expensive. So, to like run all that kind of stuff. There's another reason like why the arbitrage space is competitive. But if you want to run your own node, you can just look at like Geth, for example, or Parity, and you can run the light clients first just to like get a feel for how you do that on your own machine. And also like maintaining a copy of the entire Ethereum blockchain is quite expensive in terms of storage. So I wouldn't recommend doing a full node on your own computer unless you have like terabytes of free space to store your own information plus the entire blockchain. But if you want to run your own full node on a server, you need a server with a lot of disk space. All right, let's see. All right. All right, is a function that checks the price or crowds. All right, get the question. I got the node question. Oh, sorry. The chat keeps like jumping on me every time I try to scroll down. Do I pack all the pairs into one contract? You can run multiple bots. So you could like clone your bot. Each bot could like check its own pair and talk to the same smart contract if you wanted to. You could do like one bot per pair that all talk to the same contract. If you find profitable pairs, how many times can you execute it before it profitably goes away? There's not a hard number on that. I mean, especially if you're like one of the only persons watching the pair. There's not a hard number on it. So one thing I'll talk about is like, especially for cryptocurrencies that have volatile prices, like let's look at the bad news. Let's look on CoinGecko. Crypto is not doing great on prices today. So look, for example, like ETH, right? ETH is a pretty volatile cryptocurrency. You're talking about ETH. So like this is an example where you're probably going to find some ARBs. Like arbitrage becomes more way easier when you have volatile prices. You see how this price like knifed really fast? So that's a pretty big swing, which means exchanges fall out of sync. And that's when good arbitrage opportunities happen. So like you might have to wait to see an arbitrage opportunity. And of course they're gonna happen on these smaller things, but this is where you're probably gonna see some bigger swings, right? Because the price changes really fast and the exchanges fall out of sync. That's a bad knife. It's not that bad, but it's like almost $10 in a short swing. Okay. I can't tell how big it is. Like a 5-minute candle, maybe. I can't tell. So let's see here. Is it only profitable every day, every week? It depends on the pair. I mean, most pairs are going to have daily profits. Well, I don't want to say most. That's not necessarily true, but it would not be surprised. I would not be surprised if a pair had good daily profits. Somebody says, well, let's say if you want to switch to DIA to link, yeah, you just change the pair from DIA to link. you change the smart contract addresses in the symbol like I was showing you earlier. So basically like, here's the assets and then the addresses. And then you would change this, okay? All right, so we'll wrap up questions here pretty soon. So we've gone pretty long tonight. So it says, thanks for all the testing. Yeah, trust me. Oh, trust me. I want to do the testing because I like building my own bots. So I've definitely reaped the benefit of testing and prod myself, but I also want to share this with you guys because, yeah, I figured you all would like to see it too. How much would it cost to deploy the contract current gas prices? Yeah, just check it in Remix. It'd be like 0.0 something ETH. So somebody say, do people rent out their own node? That's what Infura basically does. They run their own nodes and they pay other people to use them. You can buy and you can basically buy access to an Infura node. There's a free version, of course. That's what I show you how to use. Yeah, so just forget about HDD. Someone says, is it better to have 0.25 ETH to start the spot in the wallet? Yeah, you can do 0.25. When you're talking about triggering the bot, like just keep a small amount in there because, don't keep more than maybe like 0.25 in your wallet in case like you end up making a mistake and it like drains your wallet. All right. Do I have a cold? I don't know what it is. I'm a little stopped up. Yeah, thanks for asking. I'm okay. I don't have COVID or anything like that. Don't worry. Will the profit automatically go to your MetaMask public account? So that's a great question. So no, the profit goes to the smart contract. Okay, everybody clear this up. Okay, so the contract is the one who holds the funds the whole time. So when you want to take profits, you need to call this withdrawal token function that I showed you earlier. So you do the withdrawal token, you paste in the token address, you take it out. If you ever accidentally send Ether to the smart contract, you can also withdraw Ether too with this function. Okay. So what's the license on the code that I'm sharing? Let's just say MIT license. So what's a good flash line amount? You could just do like the 100 Ether that I have in there. Yeah, I would not use Truffle to deploy the contract. It's super expensive. So yeah, the Infura free version is just what I showed you earlier. Go watch the replay. Just go to infura.io, just sign up, get a link, and then paste it in there. Somebody says, what is the future of DeFi and crypto? So nobody knows for sure, but this space is definitely like headed in a really big direction. I mean, I think the ability to like automate a lot of the processes in the financial system is huge. So I'm quote unquote bullish on DeFi in the long term. I mean, that is not financial advice. I'm not making any price predictions on DeFi, but it's a big deal. So it says like, what is the options for a blockchain developer? Yeah, there's lots. I mean, I go look at my Twitter account. Like I've been retweeting blockchain developer jobs like almost every day. They keep coming up. All right, guys. So I'm going to wrap it up here soon. I'm trying to burn through the last couple of these questions. How can I check the amount of tokens for withdrawal? You basically just go to your smart contract on Etherscan. So like, I'm just going to pull up my MetaMask. This is my public wallet. It's okay. I can just show this. Hold on. This is like just a dummy. This is just like a burner, not a burner wallet necessarily, but like It's public. So your smart contract, this is a regular account, but when you go look at your smart contract, it'll show you like how many tokens you have in there. So like if you've arbed like tokens, you'll see the value right here. So let's say you have like some profit, like let's say you get like $1,000 profit. You could just scroll down and you would see like, you know, the tokens that you've arbed or something. And then you get the balance, you know, you check which tokens you have, and then you paste in the address to remix when you do withdraw token, and you withdraw it that way. Somebody said, why don't I use Uniswap? So I'm not using Uniswap in this particular tutorial example for the reason I was talking about earlier. You're probably going to find, I like to like use strategies that other people probably aren't using. And yeah, everybody's looking at Uniswap. So you can change the polling interval if you want to. All right, I only got time for a couple more questions, guys, and I got to sign off for the night. You can run as many transactions as you want to. So I will probably I will probably email out the replay link tomorrow unless something bad happens, but definitely this week. Yeah, Uniswap is for degens. Yes, you can dynamically determine the size of the loan. I just didn't do it in the code example because I want to keep it simple. If you have a problem, yeah, you can email a question. The better thing to do is to jump into the membership program because there's a Slack channel in there where you can get help much faster. I have an assistant in there now who's like watching the chat and helping people out. If you email me, it's going to take longer to get a response. Yeah, if you want to add more exchanges, you have to redeploy the smart contract. Polkadot's using Rust to build their protocol. I use Remix version 0.5, sorry, Solidity version 0.5.17 for the compiler. All right, everybody, I'm gonna go ahead and sign off now. Really enjoyed the masterclass. Excited to share this with you guys. Again, the code is in the description down below. I'm gonna email out a replay link. If you signed up for the one-time masterclass, I will add this to the video vault inside the blockchain mastery program. So you can watch the replay in there as well. I'll have the code in there as well. And of course, if you join the one-time masterclass and you want to join the membership program, just reach out. I'll get you taken care of. You can get access to all the future masterclasses we're going to do. We've got a lot more exciting masterclasses coming up that I'm super excited about. Of course, you'll get access to all the past masterclasses we've already done, the weekly videos inside the video vault, you know, that 24/7 chat support in the Slack channel because, you know, nobody wants to learn this stuff on their own. And you can get a lit chat room just like the live chats in here tonight on YouTube. It's a pretty good crowd. So, of course, you know, if you want to learn how to customize these smart contracts, learn how to code Solidity, or learn how to build full-scale blockchain applications so that you can, you know, land that high-paying job, become a freelancer, you know, build your own projects. Highly recommend the Blockchain Bootcamp. You know, it'll show you how to become a blockchain developer step by step, start to finish. You know, build these smart contracts, build the interfaces that talk to it. You want to build an interface for this bot, whatever. Create your portfolio. Crush your goals in blockchain, and the Blockchain Bootcamp is the way to go. So if you're watching this on the page, then you know there's a link to a discount to jump inside that bootcamp. All right. Of course, for the mastery program, you have a lifetime discount to join as well. Yeah. All right, everybody. So that's all I've got. Super excited to do this, and I'll talk to you soon. Bye bye.